Welcome to this episode of the Thoughtworks Technology Podcast. I'm your host, Lilly Ryan, and I'm speaking to you from the lands of the Wurundjeri people in Melbourne, Australia. Today, I'm talking with Srinivasan Raguraman, a principal technologist at Thoughtworks, about a piece that he recently co-authored with our other podcast co-host, Ken McGrage, in the MIT Review. This piece is called Reckoning with Generative AI's Uncanny Valley, and today we're going to unpack a lot of these concepts and how they interact with generative AI tooling in the way that we're seeing it today. Srini, welcome to the show.
Thanks for having me here.
What is the Uncanny Valley? I've heard this is a term I've heard a lot, but I've usually heard it in the context of robotics or animation or something like that. How does it apply to the collection of technologies that we're calling AI these days?
Yeah, like the concept of uncanny valley, like you said, like you probably commonly associate with robotics, but we have seen this kind of appear in other terms as well, right? For example, in the past, when we are developing mobile application, we have been seeing that when you're building a mobile app, like a lot and often teams take a shortcut, like, okay, I have a website, can I wrap this into an app and release it, right? When the users use that app, they can quickly, for mostly it's functional, but they can also quickly at times feel cheated, right? Like in the sense, like the experience doesn't match what it should be matching with the ecosystem. So that's like that's the place like where there's a little bit of surprise or like bad feeling, like feeling the negative side of things. That's where we kind of call this the uncanny valley, and we see this appear in other technical domains, like I said, in cross-mobile platform stuff. And we also now seeing in LLM. What's special about LLM? I think LLM or generative AI for that sense is like, it's kind of a non-deterministic software in some sense, right? You can give the same inputs, but not necessarily you will get the same outputs. Like you can fine tune and instruct, try to prompt and try to make it the same answer. Even then there is not sure that you get the right answers.
And that's in opposition to something like a calculator where you would input 1 + 2 and you would expect it to be 3 every single time. That's more of a deterministic approach. So the non-deterministic, you're getting a lot of different kinds of output. And the same input could generate a wide variety of different responses depending on what the model's got in its training data set, how it's been weighted, that kind of thing, right?
Yeah, exactly. Like, a small change in input or like a small change in something that the model relies on can have a, quite different outcome, right? Like output. So I think this is kind of the behavior of LLM, which is actually quite useful as well. Like, because we can see the use cases of LLM where it's writing text or essays where that's useful to not have the same essays for millions of people giving the same input, right? While it's useful, it can also the other side of things where it can not be useful, right? Like this kind of makes it what the surprise can be, either surprise or it could be disappointing, right? This disappointing is probably where it kind of starting feeling into the uncanny valley.
This uncanny valley thing, it really describes that kind of creepy feeling that you experience when you're expecting something to be sort of human, and then something happens. There's some kind of output or appearance or something, just even for a moment, that reminds you or indicates that the thing that you're speaking to is not human. I think classically they spoke about zombies as kind of falling into this category. It's a bit spooky. It's human shaped, but the behavior, the movements, and that kind of thing don't feel the same. And so for a lot of people, that's where that uncanniness can come from. So I can see, how it applies in this situation too, where you have these moments where suddenly, if you're interacting, say, with a chatbot, in that case, you end up with something that really surprises you. And when it comes to how we look at this in a business context, why is it important to think this through?
Like I said, the uncanny valley experiences could be for many reasons. Like one of them, like evolutionary responses, right? Like our brain are wired to detect anomalies, right? Or it could be a neurological thing, like because you feel that way. But it's also very common about the mismatch in expectation of the output, right? So that's why I would probably tie it back to the expectation on the capabilities of LLM. Like the capabilities of LLM is kind of wide ranging. And now if you see the market, there's a bunch of models. There's large language models. There are even specialized small language models, right? Like how would someone make sense of this? Like whether this is the right model for me for this context of the job I'm picking up, right? If the mental model for picking that up kind of right model is not set, that kind of also reflects in the user experience. So it's not just about what the user can see. It's also like how the developers building around it need to have to pick the right one, right? This have a bigger impact in business. Like most commonly, you're probably hearing like a lot of people are like experimenting or like doing a POC or generative AI. When you ask them, have you deployed to production? The answer is mostly like, we are not sure about the implication or ramification, so we're holding it at the POC, right? I think that's where the uncanny valley experience and the impact of that is quite evident in making or even like productionizing the model.
Because nobody wants to put that experience in front of a customer. And I think we've seen many cases that have made the news where, because of that experience happening in front of a customer, there's been a lot of negative backlash, brand reputation impact, that kind of thing. And yeah, it's tough. I like the distinction that you drew there about the way that people are thinking about it in terms of their different roles. What kinds of mental models about this kind of current crop of generative AI technologies have you seen out in the wild? You know, when you're speaking to clients, when you're speaking to developers, and when you're speaking to members of the public, I think all three of those groups can really have some very different ideas about what generative AI is and can have different ideas in different contexts. What kind of mental models have you seen people have, and what do you think are the helpful ones?
Yeah, I can start with like what I can hearing from clients or people who are first looking at the LLM, right? Like the first time they look at it, it's like, oh, okay, this model can reasonably answer me and can learn from my interaction, right? Like the most common question I had is like, okay, I deploy an LLM model. Now, based on how I'm using it, does it automatically learn from it, right? Like, or most people assume that it automatically learns from it, but it's not true, right? Like the LLMs, like they have this certain modeling and then they can generate responses, but not necessarily learning from your question. They have the concept of context window where they can use like certain range of information to give us, you know, more a response that you're looking for. But like outside that context window, there's not much of memory on its own. Like it doesn't learn from you, right? Like I also think this is partially driven by like how the industry is approaching this, right? Like the one of the common thing is like when people experience interaction with LLMs, they kind of feel like, okay, it feels like it's reasoning, right? But it's not really reasoning, and it doesn't really have the basic capabilities, or it's not built like humans, right? Like it is a probabilistic model, like also called as like stochastic patterns, right? Where it just generates an output based on a bunch of parameters. It's not reasoning for you, but it feels like reasoning, right? This is tying back to like the output looks like more human, so you kind of assume that with that mental model it can reason.
So you could, for example, ask a chatbot something like, please explain how Leonardo da Vinci's Mona Lisa ties to the cultural aesthetic of the time in which it was painted. And it could probably say something about that. But you could then ask it classic something like, you know, how many R's in the word strawberry? And it's not going to be able to get to that point. That's quite a famous one. And I know that OpenAI has named one of their more recent models, codenamed Strawberry, because they were looking at how do we solve this problem? It's fundamentally one of the things that I think the industry is looking at quite a lot, right?
Yeah. So like the concept of moving towards, AGI, artificial general intelligence, is like, that's the goal, is probably useful, or like it has its own, people looking outcome of it, but like it's kind of also kind of leads to the common understanding of like, okay, should I be worried about this, or like can it actually do all the thing I can think of? That doesn't actually help people to be very realistic or like to be actually interacting with these models with the right mindset. The common story, I think, of like the one thing I found as a mental model I heard in good terms, or a framing for that's useful, is like the AI as the stone soup. Like This is a story of like, three strangers coming into a village, and they say like, okay, do you have anything to make a soup? And the villagers are like, no, we have our food, but we don't want to share with you. There's like, it's okay, we'll make a stone soup, which is very delicious, right? They kind of start putting stones and start boiling water. And then they say like, oh, it tastes nice. You just need a little bit of something. Do you have something, right? So they quickly borrow things from the villagers and slowly adding things like carrots or whatnot, right? Actually the soup, the outcome is delicious. It's not because of the stones or the boiling or the things that stranger brought in. It's about the people, what the information they shared, the data shared, right? So I think this is kind of sets the context of the LLM as a good model, where it's like, the outcome is actually determined by a lot of things that you share. It's not a magical thing to solve. So you kind of be aware of like how the whole process works and what it translates into. I feel like this is a good analogy or metaphor that actually can help people to approach LLM or generative AI with the right mindset.
Right. So it gives you this basis from which to structure your own thinking by kind of offering you the possibility of anything and then having it reflect back to you the things that you put into it and build on top of it over time as not quite a collaborator in that way that it is actively participating with you, but that it provides the framework for you and the people working with you on this to get something substantial out of it. Right?
Totally. You also mentioned about like, what's the other kind of mental models people are. The common one I can see with business is like they kind of have this assumption I can replace something with this entirely, right? Like you can call it as an automation bias where they want to automate a big chunk of thing without understanding the ecosystem, right? I think I can quote a recent example with the coding assistants, right? Like with coding assistants and other stuff, it's the outcome they want to replace is generating code, right? The coding assistants can generate code, but then is it makes easy to read those code in production when you're trying to debug, right? That's those kind of things, right? It's the assumptions people take is like I can substitute some part of the current workflow entirely with the LLM or generative AI often leads to other problems where I think you can learn from the past where automation with humans and machines is a similar thing where if you take like, for example, pilots using autopilot, right? When they're using autopilot, they're not exercising their regular skills, but they also need to know about how autopilot engages, right? There's a bit of complexity that they also need to understand to be able to step in and disengage autopilot in a place where it's relevant, right? So it's not like suddenly I have an autopilot, I have taken care of these things completely out of the human control and doing a best job out of it. It actually increases the cognitive load for the people to understand how the machines operate. I think for a human-machine interaction, there's two bits that's very important. One is the observability part of it, where you kind of want to know what the process is replacing and how it's behaving. Given a generative model, it's not a deterministic model. It makes it challenging, right? The other bit is a bit of able to direct the machine or the LLM to a specific task, right? You can do that bit of prompting, saying like, hey, can you focus on this bit and change it? But again, it's not as directive as in, like a driving a bike or driving a car, right? So this the key bit of automation that actually makes this human machine or human automation works well is the observability indirectly, but the nature of LLM challenges this, right? Like the nature of LLM is not quite adaptive for this kind of expectation. I think that's where the industry is generally moving about, like how we can improve the reliability or how we can bring the observability and the directability. And that's probably where these mental models can help them to approach it very realistically.
It's interesting that you talk about how it can be used to augment a lot of things. And you also mentioned the problems around things like pilots, understanding autopilot. There's also a concern that if you're adapting too many automated models in your workflows, that you will replace the people who are learning from doing those kinds of tasks as introductory tasks. If they've just started out their careers and something can replace them in that space, how then do we get people who are going to be seniors in, say, 10 years' time, learning the foundational skills right now? Is there any mental model there that you can... Is there an approach that you would recommend that people take if they are looking at these kinds of solutions, such that you are not only helping people with these things, but also helping people grow their skills from first principles?
Yeah, I think that's a very interesting question in the sense, also a very important one. When you're replacing something, it's kind of taking away the opportunity or the current process, right? So it is important for people to study the ecosystem. What is the second order effects of doing this and what it can imply? And if there is an impact on another role or another person, then opportunity is taken away. Then there needs to be other set of things that need to be pulled off. I read about this somewhere where, the doctors using robotics these days, right? They can actually make it very minute operations very clearly. Which probably previously, it required 10 assistants in the operation room. Now it's robotics with, robotic hands. They just have to use the robotic to control and make the operation. Usually they don't have that many assistants on the room, right? When the assistants look at it, then also they just look at the machine operating. They're not really looking at the person, how they are controlling and other stuff, right? This kind of changes the learning ecosystem for even new people. And due to the cost and other things involved, again, only people who are experts are kind of given opportunity to operate robotics, right? When someone is new in their career, there's not enough ways for them to actually do a robotic operation unless they are experts, right? In a way, I feel like these LLM or these advanced techniques kind of very useful tool for experts, right? Because they kind of know what the machine can do. And they can also sense that it's not going right or things like that very effectively. Then their knowledge and the people's knowledge is the key bit in making that whole outcome maybe 10x effective, right? But at the same time, it breaks the metaphor of, or not even a metaphor, but it breaks how other people can engage in this. Maybe there needs to be a second simulation place or a digital twin or those other things needs to be explored where people can safely move from, novice into slowly able to run. But just replacing something kind of have these second order effects. Outside this, I can also think of the AlphaGo. I think the trend after AlphaGo is the players' ranking started stacking up, right? As in previously level X is probably the golden standard, but after AlphaGo, people learn from that interaction because experts can learn from that. The player ranking went really, really high, and it's now somewhere differently, but also it changes how people can learn. Previously something learned naturally, now people have to learn it by looking at how the machine performs. Someone said it's like learning from cheat sheets, right? You're missing that foundation. You have to jump from somewhere else to be effective at that point. But how do you bridge the gap? Yeah, it raises a lot of interesting questions, to be honest.
And I think it puts a lot of responsibility on us when we're implementing systems like this to think through those second and third order impacts on the world around us, not for just solving the problem right in front of us, but for what that problem was doing in the world in the first place, and whether, while it provides a point of friction, that friction is also something that we have been learning from over time as a part of the larger ecosystem. I liked the part in the article that you wrote where you were talking about using the uncanny valley sensation, that kind of misstep, eeriness, as a way of reminding ourselves that what we are dealing with here is not actually human, and that it is a machine, and that there are things that we need to be mindful of around it. That this particular feeling is a good reminder of that and a good tool and that kind of thing. In terms of the way that people have approached the uncanny valley problem, if indeed it is a problem, in the past in many different kinds of fields. There are some folks who have tried to bridge that uncanny valley and say, right, well, the goal should be that we're getting right to the other side of the valley where we need to have something that will behave exactly like a human being at all times. And you see this in some kind of applications of animation, for example, where this problem comes up, where people are pushing the boundaries to try and have more and more realistic animation over time. At the other side of that, you have folks who are saying that the uncanny valley should just be avoided, that it's not actually worth bridging, that the goal is not about that, but it is to stay on this side of the valley and work with the thing within the limits that it has. I think for me, one of the interesting applications of this mindset was when, for example, they were animating Toy Story, which was very early on with computer-generated images, and they chose this story based on, plastic toys, because they knew that they could animate something like that without falling into this uncanny valley trap, that this fit the level that the technology was at the time, and that they could tell a good story within the bounds of what was possible, but that they firmly acknowledged that those boundaries were there. Do you think that the uncanny valley should be bridged, or do you think it should be avoided?
I think it's more about being aware of that kind of can trigger your set of things that you can, right? Like it's not something can be avoided, as in like it is something to be looked at every aspect of the work, as in like the Toy Story example you said, right? Like it is not just for the end user, it's also the people who are building it, right? Like it can show up in different places, right? The moment if kind of you show up in different places, it's also a good reminder to like how we can understand this better, or how we can make it easier for someone else to actually work with this, right? Like, I can think of like, end of the day, it's like AI is like, it feels like it can reason, but we kind of know it's a probabilistic model. Like having that mental model kind of helps you to actually approach it with like what else people can assume from it, how we can bridge gaps around it, or like how we can enable people to be aware of those things, right? Not giving them a bit of a guided exploration or like some guidance on it, kind of leading to a lot more assumptions building on top of it. That's where it's like, it kind of leads to the place where it definitely going to be an uncanny valley, where the problem of that can be catastrophic for how they interpret it, right? Like, I think this kind of happened in like data explorations at other places as well. I would say, like, for example, even you take a data algorithm, right? If it's blindly implemented, the outcome of the choice of the machine is just implemented without considering the context and other stuff. It can, and shown in many places, that it is not a right outcome, where people needs to actually question what the system is providing, why it's providing, and is the context is right. And they should have the ability to actually contextualize it.
In addition to thinking about the uncanny valley as a mental model for working with generative artificial intelligence technologies, in the piece that you wrote, you also talk about the kinds of tooling that people can implement to help minimize the likelihood of these kinds of uncanny valley moments if the choice of generative AI tooling is something that people want to pursue and go ahead with in the context where they're trying to apply it. Can you talk a bit about the ways that you would recommend people think about this in practice when it comes to minimizing those moments?
When it comes to minimizing these moments, I would probably say, like, for example, going back to the point of like, it is not a deterministic software, like how we can make it more understandable, like how we can make it reliable, right? Like there are modern techniques like evals or testing things, or like guardrails where you can make sure like these kind of things cannot leak from the building the system. You can also think about how people interact with it, right? Like not just the customers, like the developers, because their assumptions about the model can lead to an outcome that is not warranted, right? Every time a new model is coming out, like there's a question also comes in, like, is this better than the other one, right? How much better than this? All the question again is like the context of the problem you're solving, right? a new model can do better in something else, or like it can be slightly better. So as an engineer or a developer who's building this ecosystem, it's like to build measures and toolings, like testing techniques, or like establishing benchmark for like, okay, if my LLM can answer these questions reliably for these many things, then I can have some trust on it. Or I also put some guardrails which says like these things cannot happen, right? Like it's kind of building that foundation layer, you can call it, or like a layer of things that can help you to have a good sense of like that for my context of the problem. Again, I stress the context of the problem because like there may be like off-the-shelf guardrails and other stuff which can like very generic. It may give you a false sense of promise saying like, okay, this is taken care of. But the context of the problem is the key, is like where your business use case or the problem you're trying to solve have very specific question. That's where you need to go back to the first principles and find out like what is the right questions that I need to make sure if this model deploys is still valid, right? I think in a way it's like that's the role of the developers or engineers, is to make sure it's like, oh, the shiny models keep dropping, but like, does it make sense to adopt? Whether it's safe, whether it's be safely built, how people are going to interact with the system or their controls, and other places where they can actually adapt to this. Right? Those are the things I would say. Yeah.
Yeah, it's the right tool for the right job, and making sure that if it is the right tool, you're thinking through the context that it's going to be applied in and those knock-on impacts on the wider ecosystem, I think. Is there anything that you would like to leave our listeners with today in terms of thinking through how the uncanny valley could be useful to them in their work?
Working with LLMs, right? I think like previously automation is probably done, focused main on like replacing mundane tasks, or like, can I do this efficiently? Or under part of times using machineries and other stuff. But LLMs kind of, I think people are engaged in a creative work with it, right? Like as in like, can you generate a nicer image, or like, can you generate a bunch of ideas or an approach, right? This is kind of more of a cognitive work, right? When you're doing a cognitive work, it is very important to, even when you're working with someone else, it's kind of establishing what is the outcome you want to achieve, or like my assumption about the other person, or like what are they thinking through, is this correct? It's like reducing those feedback loops, or like how we can course correct, right? That becomes paramount. So I think that's where like for everyone, this concept of uncanny valley is like kind of could be a good reminder about, okay, do I understand about the other side of the things enough? Why did I fall into this, right? Like what are the things can be looked after, or like would someone else also love this in a way, or like is it something trivial, or is it going to actually have a knock-on effect, right? I think this concept of thinking through this, like what would I feel when this happened, and why did I feel through this, and kind of the constant reminder of it's a cognitive work. When you're working in a cognitive work, this common understanding and knowing about the other side of things is quite important.
Well, Srinivasan Raguraman, thank you so much for joining us today on the Thoughtworks Technology Podcast. Been pleased to have you here.
Thank you. Thank you for having me.